Alright, hi everybody. Today we're going to be solving another problem. So here we're trying to find the gate width for each of these MOSFETs, and they're all NMOS. Now we're given some information here, and we're going to be applying this to figure out what the gate widths are. Alright, so we already know the famous equation, drain current equals 1/2. It would be normally K, but here we're going to use these values. So we have 100 micro times W over L, in this case 1 micro, times VGS, which in this case we're going to solve for the bottom transistor first. It's going to be 0.8 volts minus, and then VT, which is 0.5. Okay, awesome. Now, we know the drain current to be 100 microamps, so we're going to fill that in, equals 1/2. And the micros here can cancel out. 100, and this is also a 1, so we can just leave it as W. And sorry, this is squared. 0.8 minus 0.5 squared. Alright, nice. Now, we can combine this to get 50 and divide this by 50. So we're left with 2 microamps equals W times 0.8 minus 0.5 squared. Alright. Now, we can combine this to get 0.3 squared, which is going to be divided by here. And to save us the time, I believe that will leave us with 22.22 micrometers equals W. We'll call this W1. Actually, W3 to match Q3. Alright, sweet. So we got one answer. Alrighty, moving on to the next one. Oh, goodness. And now it froze on me. Okay, sorry about that. So now we're going to move on to Q2. I'll label this just as Q1. No, Q2. Okay, it's very similar. So ID, which you're going to place with 100 microamps equals 1/2 100 W2. And now this is where things get a little different. We're going to have to subtract, we're going to start out with 1.5 minus this. So it's going to be, well actually it's going to be minus 0.8 minus 0.5. Because now we have a difference here. Okay, we can't just leave us 1.5. That would be way too big. We need to account for the difference. The difference in, oh, I cannot do that. Oh my goodness. Now it just like freezes when I do that. Alrighty. Just give it a minute. Okay. How am I going to do this? Here we are. Okay. So, right, so we have to do it like that. Okay. So now we're going to have 100. Oh, okay, let's go back to blue. Alright, we have, well, we already know from over here that this is going to boil down to 2 microamps equals W2. And then doing this, we would get 0.2 squared, and this would leave us, again to save time, it's going to be 50 actually, is that correct? Let me just double check that. Yeah, 50 microamps, micrometers. All right. We got W2. Now let's get a W1. So now we have Q1. Nice. Okay. Very similar setup. 100 microamps equals... Actually, we don't even need to write all that. We can just keep it as 2 microamps equals W1. And now we're going to be doing... We start with 2.5 up there. 2.5 minus 1.5 minus 0.5. We're always going to have that VT there. Squared. Alrighty. Now, you can just simply combine that to get 0.5 squared. And this should give us 8 micrometers. Alright. And just like that, we were able to calculate all the gate widths. Alright, thank you for watching. I'll see you guys next time.